Good morning, folks. I'm audible to you all. Hi, hello. Good morning, very good morning. Okay, I think it's a new day. Let us start this refreshing thing of routing aspects. Very clean and clear. I think you have been cleared with all your doubts till yesterday, right? So you need a quick recap on it. Yes. Yeah, we will take care of it. So we'll take care of the quick recap and we'll plan the session. Okay. So if there are any disturbances with my voice or my audio, please let me know immediately so that I can respond. Okay. So please don't take any delay. Okay. Are we good to go with the session now? Still, I want to wait for a few many number of folks to join the session. Are we good to go? Okay. Yes. So I'll just open the tool. Yeah. Give me a moment, guys. It will load. So fine, we got the setup, and you are very familiar with the setup as of now, right? So the first thing is, whenever there are multiple nodes which are connected to a similar network, they should fall within what? Within the same network address, right? Is my screen is visible to you all? It should fall within the same network address. And also we troubleshooted that. So in case of any of the additional heterogeneity of the network address has been added on the particular LAN, so what would be the issue? So it will never respond or it will never communicate even though the static route is being configured, right? So that was the issue we have seen yesterday. Yes or no? Yes, yes. So now I'll just ensure with one thing now. So what is network? I mean router hop IP. What do you mean by router hop IP? What do you mean by that? Yes, can you give me the answers now? Yeah, next router's IP address, right? Next router's IP address. So whenever the static route, is that clear? Whenever the static route need to be configured, it need to be configured only on the routers, right? Yes or no? It need to be configured only on the routers. Whenever a static route need to be configured, it can be configured only on the routers. So when it is needed, it is needed only when the router are not aware. If the router are not aware, if the routers are not aware about the remote located network. Remote located network. Yes. Yes, right? This is the definition now. When is the static route is needed? Whenever the router is not aware of where the remote network is located. Just to access that network, we need static route need to be configured. Yes? Clear with the concept? Yes. So now to configure the static route, so there are scenarios that can be considered, right? There are scenarios that can be considered. So what are the scenarios? One is with respect to next hop IP, and the other one is exit interface. Exit interface, exactly. One is next hop IP and the other one is next exit interface. Yes, exactly. So based on this, you will be able to identify that particular network which is being added on that route. Is that clear? The concept is clear, guys? Yes. Any doubts in this? Any doubts over this concept? No. Are we good to go with the next criterias that we need to meet? Okay, someone is asking for repeat. So what is the need for static route? When a router connected to multiple network, when a router is connected to multiple network, and if it is not aware of this any of the networks, then we need static routes need to be created. So the static routes can be configured only on the router which is looking for less than 4 networks. So we know the criterion, right? Static route can be configured only for maximum limitation is 4 network. So 4 is also multi, right? 4 is also multiple, right? Yes, it is not single, it is also multiple. So when the static routes can be configured, when the router is not aware of any of the network which is directly connected to it, apart from that, then the situation of static route need to be configured. To configure the static route, there are two criterions. Either this criteria, that is next hop IP of any of the routers that you are looking to configure with the static route, or the exit interface of the next router, the exit interface of the next router. So based on that, we will be able to configure the static route. Is that clear, guys? I think I've given enough explanation on this. Yes? Okay. So any doubt? Any doubt on this? No doubts, right? Okay. Sir, can you unmute me? Okay, one second. Who is that? Asking for. Prashant. Okay, Prashant. Wait, Prashant. You can unmute yourself. You can unmute, Prashant. You can talk.
Hi, sir.
Yes, Prashant. Hello. Good morning.
Sir, can you show the first demo? Starting static routing.
Starting demo, is it?
Yes, yes.
One second. I'll just look into it. I deleted it, I think so. I'll look into it. If it is available. Okay, I think this file name was simple routing, right?
Yes, yes.
Simple routing, I think so. I'm not sure. Let me check one second. Is my screen is visible?
Waiting HTTP something.
Yes. It will take time. 1 second. It will load because the configuration is something like that. It will take some delay. It will load. I think I deleted it, Prashant. Yeah, what is the doubt, Prashant? Please tell me.
You connected some PC1, PC2, right, sir?
When in the first configuration.
Yes. PC1 R1 and R1 to R2 and R2 to PC2, right, sir?
This one, right? This is the configuration you're talking about?
Not, sir. First one.
First one, which is the one? Okay.
First demo, static routing demo. First, you tell me, sir.
Okay. So there were 4 nodes, right? In that?
Yes, sir. PC1,
Okay,
PC2, R1, R2.
I'll look into it. 1 second. Give me a moment.
Okay.
I'm not sure whether this is simple demo. Okay. Fine, I'll look into it.
Maybe it was saved, sir. You can check in the file.
Yeah, I have opened that file, but it is not visible to you. That is what. Okay. Only the GNS interface is only visible to you all. I think it should be there. 1 second. See, this file was saved, and I'm just checking with the other file whether it is saved or not. 1 second. Okay. Once again, Prashant. So if I'm not wrong, Prashant, so this was the scenario, right? This was the scenario.
Yes.
Right? This was the scenario. Yes. Please tell me now. This is PC1 and this is PC2. Yes, tell me.
If not PC2 is not connected to R2, sir. If to R2 connected to
PC2 is
R3,
connected to R2. This is R1 and this is
Uh,
R2.
if we delete
PC2 is
the
not connected. Yes, yes, tell me.
if we delete the connection R2 to PC2, sir. Okay, connect. If we establish a connection between R2 and R3, we create the one more router, sir.
Okay, I created one more router. Okay, fine.
Okay, serial connection, sir. R2 to R3.
Serial connection. Okay.
A normal connection, either a serial or normal. Okay, but
Okay, fine.
we connect the PC2 is R3, sir.
No. Please, I didn't get. I'm missing somewhere with your points. Can you please repeat?
Delete the connection between PC2 and R2, sir.
So this connection.
Yes, sir. Connect
Okay,
the PC2.
So
Connect
you
the
want me
connection.
to delete this connection, right?
Yes, sir.
Once again. Okay, I have deleted that connection. Okay, fine.
Connect the PC2 connection to R3, sir.
R3. Okay, connected.
So if we ping if static routing from PC1 to PC2, if routing interface is R3 exit interface.
Exactly. See, because now R2 has become completely isolated from PC2 now. Okay. R2 has become completely isolated from PC2. So who is mutual for R2?
R3, sir.
R3 is mutual, right? R3 is mutual for PC2 as well, right? So according to the knowledge, so where the static route need to be configured now?
Exit interface R3.
No. See, for R2, PC2 will be the destination, right?
Right. Okay.
Yes. So R2 is looking for the destination. Now R2 should be configured with static route, right?
Yes, sir.
Yes, R2 will be configured for static route.
Starting routing. Oh, yeah.
Yes, exactly. Got the clearance?
R1 to R2 plus R2 to R3, yes, sir.
Yes. See, if R3 is isolated from which all the networks? So how many networks are created now? For example, how many networks are created? Network 1, network 2, network 3, network 4. Right?
Yes.
There are 4 networks altogether. There are 4 different network addresses are there, right?
Yes, sir.
So this is different, and this is different. But is R1 is aware of R3's correspondence? No, right?
No.
Even it is completely isolated. So static route need to be configured on R1, and also static route need to be configured for R2 as well.
R2.
If they are looking for PC2 as a destination, is that clear?
Yes.
So if R3 is looking for PC1 as a destination, is that clear? If R3 is looking for PC1 as a destination, then where we need to configure static route?
R3 to first we configure.
We need to configure in R3, right?
Yes, sir.
If R3 is looking for PC1 as a destination, then R3 should be configured for what? It need to be configured for complete static route. Exactly. Yes, that is what. Rather than to the directly connected network, remaining routers need to be configured for static route. Very simple definition. Someone gave the right answer. Is that clear, Prashant?
Okay, sir.
Okay. So there is no any confusions. So people will find very easier by putting exit interface. People will find easy while putting while nominating with the next hop IP. Anything is fine. So it is according to their comfort zone. So all are acceptable. Clear?
Sir, excuse me, sir.
Is the concept is clear, guys?
Hello, sir. Excuse me, sir.
Yes, who is this?
Sharik is speaking.
Zahid, yeah, please tell me.
Sir, in this topology, when we are configuring for R2, what is going to be the next hop IP and exit interface?
Which one? For R2. R2 we are not configuring static route now. Which is the destination you are looking for?
Destination, sir, PC2.
PC2 is the destination.
Yes, sir.
Okay. R2 is not aware of the 4th network, right?
Yes, sir.
R2 is not aware of the fourth network. So exit interface will be R3's towards PC2.
Okay, sir. And next hop IP, sir?
Next hop IP will be this one, this one. This one. The interface which has been configured of this IP address.
Okay, sir. Fine, sir. Thank you, sir.
Okay. Clear, guys?
Yes, sir.
Okay, it is taking some. I think I deleted that scenario. I'm really sorry for that. But it is booting up. Okay, fine. No issues. If the concept is clear for you, no issues. We'll switch on to the next concepts. Are we good to go with the next concept now? Okay, thank you. I'll just shut it down. Okay. We'll look into the next concept. The next concept is loop back. Loop back address. Is that clear, guys? Loop back address. So it doesn't require much of the time. So there are few points. I'll just type something like this. LP loop back address. Loop back address are the one which is associated as continuous series, or with representation of 127.0.0.0 network IP address. Also, it determines full subnet mask value by providing virtual self interface for respective routers. Yes. Have you heard about this loop back? No, right? Okay. Loop back. So what is this? Just tell me now. What is this? 0 to 127. What is this? What is this? It is a class A representation, right? It's a class A representation. Agreed? It's a class A representation. So the last network address of the class A will be always dedicated as loopback. So it is standard. So it is not set by any of the network administrator or anyone else. It is a standard default. Whenever this address has been given, so immediately you can say that it's a loopback address. For example, so I'll just run the command prompt ipconfig. So what it will give? It will give the status of my IP address, right? It will give the status of my IP address. Yes or no? Yes. So this is my IP address and this is my subnet mask and this is my default gateway with respect to my modem. This is my default gateway. So here everything are similar to the network address, right? Everything are similar to the network address or not? The two addresses. Yes. So when I give ping 192.168.29.25, for example, will it take the ping? Guys? Yeah, no, right? It will not take the ping. Yes or no? It will not take the ping. Why? Because it is my self address. It is my self address. Yes, exactly. It is my self address. For example, you'll be having two names, right? You'll be having two names at home place for calling you as calling you with some other alias names. They will use some other names, right? Nickname. Exactly. Your friends will use or someone will. So, will the world will recognize you by that name? No, no. It will be recognized by the actual IP address. But the nickname will be given. So, whenever they call your name, you will turn up, right? So, likewise, in the configuration of network, so there is a virtual create. I mean, what is virtual? For some amount period of time. Yes or no? For some amount period of time, it will be alive. Not for the entire world, only for the limited areas. Only for the limited areas it will be there, right? So now, see, this is my address. This is my IP address. When I'm trying to ping this IP address, I'm not getting the response. But instead of this address, what I do, I'll ping my gateway. I'll ping my gateway. Let me check whether I'll get the response or not. So, I'm not getting. Type the right address or not? 6829.1 exactly. Okay. Now what I do is, so there is some issue. 127.0.0.1. I'll just ping this address. So what is this? What is this address? It belongs to loopback version, right? It is a loopback version. See, am I getting reply? Virtually, this address is self-looped on my interface. On my network interface, it is being self-looped. So to check that aliveness of that particular device, so we make use of this address. And this address will not be dedicated to any of the host interfaces. It will not be dedicated to any of the host interfaces. Is that clear? No, it differs. It differs. It differs completely. It differs completely. See, I gave some definition, right? Which is associated as continuous series. Did you got this? Which is associated as continuous series. So what do you mean by continuous series? Consecutive values. See, I'm getting the reply or not? Consecutive values. Fine. So I gave 1.1, 4.4.4.4. So it is not taking because only 1.1, 1.1 is being assigned as a virtual address by the network administrator. It is assigned by the network administrator to know the self check of my healing status of my network. So in which kind of situation we'll make use of it? Only in case of troubleshooting, we'll make use of this loopback interfaces. We'll configure this loopback interfaces. No, 0 to 127 is not. See, the occupancy of class A address only belongs to the first octet. Don't get confused. Only belong to the first octet. So how about, for example, so this is the representation, right? Yes or no? This is the representation, right, for class A? Yes. So why we are given 255 to the first octet itself? Why we are not taken for the remaining rest of the area? It behaves as a host, right? Only the first part will behave as a network. Yes or no? Yeah, the rest of the bits are acting with the host bits. Yes. So the rest of the interface, no, I muted it. Don't worry. I muted it. So 8 is the network part and the rest of the bits are host part, right? Yes, exactly. So how you got this? For example, you know the series, right? You know the series 64, 16, sorry, 32, 16, 8, 4, 2, and 1. You know the series, right? From binary to decimal and decimal to binary conversion, we make use of the series, right? So, for example, if I'm applying 1 here, and rest of them are 0, what will be the value that I'm going to get? 128, right? 128 belongs to which address? 128 belongs to which address? It belongs to class B. Yes or no? So now, apart from that, the first bit will be unchanged and the rest of the bits will be nominated as 1. So what will be the total calculation that you will get? The total calculation, what will you get? So when you sum up all these values, left out with 128, you will get 127, right? Yes, 127. So the occupancy of 127 only lies with the first bit. That's it. Sorry, the first octet. So apart from that, everything is host bit. So it is not that from 0 to 127, everything is. No. It is not that situation. 0 to 127, it is not completely the loop back. Only the 127, and if you are configuring with the continuous series as a loopback interface, then only it will be loopback. So until and unless you are configuring this continuous series or with the representation of 127 network part, then it will not be the loopback. Is that clear? Is that clear? So why we require loopback? To check the troubleshoot, and also to check the healing status of that interface or that device. Yes. Okay, I'll repeat it. So the loopback can be configured in 2 ways. One is the continuous series and the other one is with the representation of this network address. But it determines the full subnet mask. What is that full subnet mask? It can't be situated with 225.0.0.0. It can be situated when you are applying with the continuous series or with the 127 loopback. It should be situated with something like this. Is that clear? So what it declares when I am assigning everything as this, what it declares? So all the octets are acquired with host bits, right? Yes or no? Tell me. All the octets are acquired with host bits, right? So how many host bits are acquired now? How many host bits are acquired now? 32. Yes. So there is no room for network occupancy at all, right? So what does that mean? So only for one particular host we are dedicated the complete bits. Is that clear, guys? Is that clear? All the 32 bits are dedicated for only one host configuration. Only one host configuration with respect to what? With respect to this part, the continuous series. As I added 1.1.1. So it will vary from from one host to other host. So it can't be only one or it can be only 2 continuous series. So it can be completely discrete. Okay. With representation. So what is that question? No, I didn't get it. What is that question? But sir, 225 we treat it as network bits. No. See, for class C, how many occupancies are there till here, right? How many network bits occupancy are there? 24 network bits, right? Yes. So if you are trying to configure for class D, for example, have you got any other bits? I mean, octet represents with the network bits? No. Everything will be occupied by the host bit itself, right? Everything will be occupied by the host bit itself, right? So can I easily conclude that? So this kind of loopback representation is mainly used for what? It's mainly used for multicast troubleshooting. You are aware of this term multicast, right? Unicast, broadcast, and multicast. Yes. So it is used for multicast troubleshooting. So class D is used for what? multicast, one to many. Exactly. It is from many to many and also from one to many. One to many absolutely speaks about the broadcast. So one individual communicating with everyone. So what type of communication we are doing now? I'm communicating with so many number of folks, right? So it is a broadcast that I'm trying to deliver here. When everyone are talking from there, and if everyone are talking at my end as well, so then what it becomes? It will become completely multicast. It's a many-to-many communication, but it is dedicated for self-healing and troubleshooting issues. Yes. Is that clear? Is that clear for? Yes. Okay. The next one is I think yeah. So now how to verify the static route? Loopback is only for class A. Yes. Loopback belongs to class A address itself, not for class B. No. Yes, exactly. Loopback address always situate in the class A itself. It will not be at the part of class B. Exactly. And it is classless. It is not classful. Loopback addresses are always classless because we are giving the complete representation with the whole mask value, right? All the 32 bits. It is completely classless. Yes, 4.4.4 is also a loopback. Exactly. Yes. Okay. So now how to check with the it's something like verifying how to know about the static route. So there are few parameters here, guys. There are few parameters here. For example, destination network address with subnet mask detail, right? Whether it has been occurred in your output or not. Did we saw this output? Destination address. Did we saw this? Destination network address in the previous example, did we saw this or not? Yes, we saw it, right? Yeah, we have seen this. Destination network address. We configured and we saw that. Yes. Next, exit interface. Next hop IP address, right? Next hop IP address. Exit interface or next hop IP address. Where it is? Can you see here? I think in this problem statement, they have configured it for exit interface. So that is the second value. That is the second value that whether it has been correct or not. Next, which is the next one? The route is denoted with code S in the routing table. We saw this as well, right? This nomination also we saw it, right? Yes, exactly. This nomination also. So what it indicates? It indicates static. Can you see here? The same thing we witnessed in our routing table, right? In the previous configuration, what we demonstrated. Yes. And the next one is the third one is static. The last one is administrative distance. Administrative distance. See, guys, for static routing, always the default administrative distance, whichever the architecture it may be, the default administrative distance, we call it as AD value. We call it as AD value. So this default administrative distance always it will be 1. It varies from version to one protocol to other protocol, but for static routing, always the default administrative value can be 1. Default, I'm talking about default. So, and also you can manipulate this default value. Is that clear? You can also manipulate this default value. Is that clear, guys? So what are the things that we need to look into for verification purpose? In the point of verification, what are the things that we need to look in? First is whether the destination network is being added in my routing table or not. What is the question? Repeat. Destination network. What is AD? Okay, what is AD value? You're talking about what is AD value. See, guys, it is an administrative distance. So for any number of any structure of the architecture that we go across with the topology, it will be manipulated with 1 administrative distance. Is that clear? From source to destination. From source to destination, it will be administered with one administrative distance. Is that clear? So now this administrative distance is looked upon with the arbitrary conditions. So I mean, in the previous example, what was the arbitrary condition that we have come across with? So how many administrative distance? For R2, it was looking for which one? This network, right? For R2, it was looking for this network. For R1, it was looking for this network. So the network which is completely isolated from those routers, it will be looking for. So by default, a administrative distance will be created for each and every network whenever a route is being evaluated. We gave some condition, right? Something like we gave IP route, destination network, subnet mask, and next hop IP or exit interface, whatever it is. We gave something like, right? So once we give this, by default, that distance value will be evaluated. When we are configuring for the static route, an arbitrary value of 1 will be automatically created. By default, it will get created. And this can be altered or this can be manipulated. Is that clear? This can be altered and also this can be manipulated. So for manipulation also, we got some set of procedures that need to be done. So what is that procedure? Let us have a look over. Can you see here? Can you see this? Syntax to configure static route with modified AD value. That is, we are trying to customize the AD value. Are you getting it? We are trying to customize the AD configuration. So what is that? After the exit interface or next hop IP, you give your value. So this value can only be limited. Is that clear for everyone? This value should be limited. So what is that limitation? The limitation should not exceed more than 255. So the limitation should be between 0 to 255. Is that clear, guys? Is that clear? So usually in smaller networks, we will not go for AD value modification. Is that clear? Usually in smaller networks, we will not go for AD manipulation. So when there is a huge number of networks which has been additionally added larger than 4 network, so we'll make use of AD manipulations. Is that clear? Okay, what is the question? See, we manipulate this AD value to know the trustworthiness of the complete topology. Trustworthiness of the complete topology, whether it has been identified with only one route or whether it has been giving some other external routes or not. Just to know that, we'll modify this network, because if it is a 4 network, so it is very limited, right? We'll be able to easily identify. If it is exceeding more than 4, it is very hard or it is very hard enough for us to monitor or evaluate the completeness of the path. So for that kind of instances, we make use of AD value manipulation. Exactly. Yes. So you got an idea of AD value manipulation. So it's an administrative distance value. For static route, always the AD value will be 1. Can we let us check in our configuration whether it is displaying the same? Let us check it. Okay, it is not turned on. Okay. Let me check here. In R2, I mean in R1, let me check the AD value. We need to complete it as soon as possible, because I need to give you the practice time. Yesterday there was no sufficient time to get for your practice, right? So show IP route. I will just check with the show IP interface brief first. Okay, so the addresses are up and running. Show IP route. So directly connected static route. So the AD value, it is not being calculated yet. 1 second. I think it is taking the earlier configuration itself. No issues. 1 second. Show IP route. Okay, it is also taking the earlier configuration itself. AD is the, yeah, AD is used to select the best path. Exactly. When there is many number of path over the network, so AD is used to select for the best path. So as less as the AD value, we can consider that it is a best path selection. If the AD value is very less, it need to be treated as best path selection. Exactly. Okay, we are not getting here. Once again, we'll check it for the ID value. We'll check it later. When we configure any of the other topology, we'll check it. Yes. So let us not rush on with that same. Are you clear with the ID value now? Just tell me the concept of ID value. AD value. AD gives us the distance of path. No, it will not give the metric of that path. It will evaluate the best path selection. That's it. It will evaluate the best path selection. Exactly. Okay. For AD value, see, if that network was working fine, I would have shown that. Let us configure one more network and I'll show it there. Don't worry. Okay. Let us configure one more network and show it there along with loopback configuration. Okay. I'll show it there. Okay, I
Welcome
think
to
some
the
video is there.
video
One
on
second, let me check.
static route. We have also learned that the depopulated AD value.
Can you see the table here? Can you see the table? Connected interface, it is 0. It will be 0. There won't be any AD values, which is immediately connected. For static route, the default value will be 1. The default value will be 1. So here, for your terms, EAGRP you will be studying, and RIP I'll just introduce, but the completeness of the RIP you will not be studying. Okay, only how to give the authentication and how version 2 works. I'll just explain that in the dynamic routing. And the default route is 255. Is 255 is a better AD value or not? Tell me whether choosing 255 is a good AD value or not. No, it's not a good practice. It's not a good practice to have 255 as a AD value. Yes or no? Yes. So among this EAGRP till 90 you will study. Till 90 you will experience. Till 90 you will experience all the ED values. AD values. And for RIP also you will experience 120. And for external EAGRP we will not be studying that. And I think OSPF is there. Yes, 110. 110, 90, 1 and 120. You will be studying all these AD values. So I'll just annotate here. So starting from static route. So connected interface, of course, 0 by default. So we need not to look up into that again and again. 1 is the static route. And the next AD value that you will be studying is 120. 120 default. I'm talking about only the default AD values. And the next one will be with respect to OSPF, that is 110. And the other one will be EAGRP. It is 90. Till here you will be studying. So this belongs to static routing, and this belongs to RIP. This belongs to RIP. RIP means not rest in peace, routing information protocol. Okay, it is OSPF and it is EAGRP. Yes. So these are the elements that you will be studying with respect to AD conditions. Okay, these are the elements you will be studying in your content with respect to. So our remaining table, need not to worry about that. So I'll just show you how the AD value manipulation is taking care in this video. Once again. See the loopback here. Can you see the loopback address how they are giving? If the network address is continuous with this series, and it can also be discrete to add the IP address. To add the IP address, it can be discrete. To add the IP. Is that clear? Is the voice clear now? Yes. Let us check with the AD value
and
now.
both are in down state.
How it has been manipulated. So everything is static routing configuration here.
In table of R2. We could find that it does not have entry for loopback interface
Is the audio is audible? The video is audio? The video audio is audible? Yes.
of R1. So we will add it as a static route. We will be using syntax 1 for static route. F0/1. Check the routing table of R2 again. As you can see, puts /8 network for interface F0 with manipulated AD value. We will one of
One second.
8 network for interface F0/1. As shown in the syntax 1 of static route with manipulated AD value, we will change the AD value of F0/1 from 1, for example, to 7.
Can you see that? What she did? She has changed the AD value to 7. From 1 to 7, she has changed it. Are you getting it? So this is the IP route condition, destination network, and also she has provided the subnet mask here, and with the exit interface she is opting with, right? She is providing the exit interface. So after providing the exit interface, so what she is providing, rather than 1, she is providing the AD value as 7. Are you clear? Am I audible to you? Yes.
The routing
So
table of
it is not something like why, because you can manipulate, that's it. If you ask me whether you are eating by your hands or by your spoon, it is upon your customization. Okay, so whatever it is, I mean, you can manipulate. Only the limitation is from 0 to 255 is the maximum limitation.
R2. The traffic goes via only F0/0 as it has lower AD value, which is 1. Suppose the interface F0/0 is in shutdown state. Again, check the routing table. We could find that the traffic is now routed via F0/1.
See, if you manipulate the AD value also, it will take the default condition itself. Even though if you are manipulating the default AD value, see, that is what the scenario happened here, right? She manipulated it for 7, but it is not taking opting with the 7. Means always it will consider the default AD value itself. It will not go across the default AD value. Always it will stick, because we'll always choose the best minimum path, right? Best minimum path conditions, right? So will you navigate, for example, if you want to travel to US, I mean, you will take the flight which is very nearby journey, right? Will you take the flight which is giving more number of hop conditions? No, right? You will not take the flight which will leads to more number of hop conditions. You will take the minimal hop condition and you will act accordingly. So thereby, this condition of static route always gives a significance default AD value, that is administrative distance value, as 1, even though if it is manipulated. Then also it will consider the minimal hop, because always it will be configured whenever the routing status is being given. What is the use of modification? When there is a huge multiple networks which are attached to the router. When there is multiple networks are attached to the router, then it will create the condition of chaos, right? So the router will be in a confusion which is the path that need to be selected. So by configuring these kind of situations, then it will be able to allow the traffic when the traffic need to be started with a minimal flow from source to destination. So for that, we manipulate the AD values or we'll keep the default as a AD value. That's it. So that is the theory about AD value. You can go across these videos, no issues. Next is default routing. You need not to put, Chetan, you need not to put anything. You need not to put anything. It will take, even though if you are manipulating, it will take the default AD value. So whichever is best, it will take the default AD value. Yes. Yes, let us come to the scenario of default routing now. See, I'll tell you, default routing is nothing but the condition applies with 0, 0. The condition will apply with, 1 second, I'll just take this shell. Zero, 0, 0, 0. So this is the value of IP. This is the value of IP. And again 0, 0, 0 and 0. This is the value of subnet mask. Always when we are configuring with the default routing, right? Default routing. So the value should be assigned with 0.0.0.0 and 0.0.0.0. Is that clear? Is the concept is clear? The default, how we are giving the default values? Yes. Now what happens here is, let us check what is default, why we need to configure this default route. Whenever a router needs to connect to a remote network, static route for the remote network should be present. Yes or no? That we satisfied, right, with the demonstration yesterday? Yes. Did we satisfy this demonstration of this line? Static route for the remote network should be present in the routing table. So which routing table? Router which is completely remote to that network, right? Yes. If there are n remote networks, then you need to configure n static routes. So one of our friend Prashant asked that R3 as an example, connected R3. So can we treat this as a n number of networks? So for R3, okay, fine. Again, R4 will be there, and again R5 will be there. Yes. So in this kind of situation, so what should be given? Because we can't configure the static routes for each and every router, right? Again and again. Is it a good practice? It will kill the time of the administrator. Yes or no? It will kill the time of the administrator. So rather than that, however, there might be a case wherein a router has only one way to reach all other networks in the topology. Yes or no? Yes. So in the case, for example, let us take the scenario. Let us take the scenario now. One second. I'll draw it first. Okay. Oh, what happened? Having some issues with this. Oh shit. I'll take this itself. So we came to know, right? Network is also having some issues. However, we try to drag in. Okay. R1, R2. So how many possible routes does R1 has got to reach destination? PC2. Only one, right? Yeah, only one. So in this condition, we are able to assign with the static routing, right? Yes, think that R1 is connected something like this. It's connected something like this for many number of networks to reach destination. Is that clear? So what happens is, we need to configure the static route on each and every router which is completely isolated from that network, right? Yes or no? See, this is one network, this is second network, this is third network, this is fourth network, and this is fifth network, and this is sixth network, and this is seventh network, and this is eighth network, right? How many number of networks are there? Yes or no? Yes, totally 8 number of networks are there while connecting from R1 to different scenarios, right? Different scenarios. See, from how many networks R1 is isolated now? From how many networks R1 is isolated? From 4 networks. That is, okay, it is isolated from this one, 1, 2, and it is isolated from this network as well, 1, 2, 3, and it is isolated from this network as well, right? Totally 4 networks it is isolated. Is that a good practice to assign the static route on each and every router to configure R1? No, right? So it's not a good practice at all. So in this kind of situation, in this time, it is time consuming for the administrator. So R1 has got a feasible path. Of course, I completely agree with that. R1 has got a feasible path. But we also need to look into the aspect of how many number of networks which are leading to the destination, right? Yes or no? So that also should be one of the criterion. So if that criterion is considered, it will be easier for R1 to just route it in a minimal way or to choose the best path. Yes. So in that aspect, let me go back to the slide. That is, as only one route way to reach all other networks in the topology. Instead of creating multiple static routes, you can have single default route. Is that clear, guys? Is the concept is clear to you? You can have single default route. So, I mean, let us approach with the demonstration. No, don't worry. Let us approach with the demonstration. So, can we take the simple one now? Shall we take simple one? Yes, let us take the simple one now. And also, please get familiar with this. So, what is this? I'll just copy this to the notepad. Just copy this to the notepad. Yes. Okay, this is the syntax. Syntax of default routing. Syntax of default routing. Familiar with this? IP route is that IP address is given? The destination network address is given? No. The destination network address should be completely 0 on all the octets. And again with the subnet mask also, it should be completely 0. Only thing is you can provide the exit interface. So no next hop IP. No next hop IP here, only the exit interface. Is that clear, guys? The syntax is clear for everyone? Yes. So let us build this network on GNS3. Yeah, let it get booted. Something like default routing. Okay. Happening here. I'll just shut down this and I'll just restart it again. Give me a moment, people. So I'll take the previous simple scenario, what we worked with, the same scenario, and let us go ahead with this. Okay. So is the scenario is okay? Is the scenario is okay now? Simple scenario. Yes, guys. Okay. We'll check the how to configure it. Okay. So that is the agenda, main agenda here. Don't tell that. There are no multiple networks. If you want to try on multiple networks, you can try. I'll just give you the simple way of approach. Let's open the notepad now. So which is the scenario we are creating here? It is default routing. Now tell me R1's interface. Yes, guys, I'm audible or not? Not getting what to wait. Yes, okay. So let us add the IP address, configuration terminal. So let us add the IP address now. So I'm configuring with respect to R1. I'm configuring with respect to R1. So let us add the IP address now. So before adding the IP address, we need to configure with the interface, which interface we need to add. Is that clear? So I'll just take F0 bar 0 as the interface, and I'll just add this network as 10.0. Or yeah, F0 bar 0 is leading there, right? 20.0.0.1 I'll just take, and 255.0.0.0.0. Fine. So this is about adding the IP address. This is about adding the IP address. Clear? After entering into this interface. So this interface is being enabled with this IP address. Is that clear? So now what we do is we'll give no shut. We'll give no shut and end WR. End WR. Copy this. So one more interface is there. So what is that interface? F0 bar 1 is the next interface, right? F0 bar 1 is the next interface. So this interface I'm talking about, this interface, right? So with respect to that interface, I'll give the assignment as 10, right? So what we do is we'll go to R1 console, and we'll just copy everything and paste it here. Fine. Yes. So let me check show IP interface brief. So this will give you what? Whether the IP address is configured and up or not. So as of now, we are good to go with the IP address configuration now. I mean, we are good to go with the R1. We are good to go with R1. Everything is done on R1, assignment of IP address. So now what we are supposed to do, we'll take care of R2. We'll take care of R2. We'll take care of R2. So what is R2? Sorry. R2. So here I'll just copy down everything as here and I'll just paste it here. So what should be the R2's interface? Just tell me what should be the R2's interface. So it is having F0 bar 0 towards R1. So F0 bar 0 is here. So I'll add dot 2 here, and next F0 bar 1 leading with the other network. So I'll add 30 for this network. Is that clear? 30.0.1 is the other network. Now what I do is I'll just copy everything. I'll just copy everything for R2's configuration. I'll go back to R2. In R2, I'll just paste it, all the configuration details. So let us check with R2 now. Show IP interface brief. Show IP interface brief. Okay, so we are good with R2 as well. Now we are good with R2 as well. Now let us go with this one, which is PC2. Okay, and this is PC3. Yes. Nilesh, yes, please, you can talk. Yes, Nilesh. Nilesh, you can talk to me. Hello. Prasanna. Yes, Prasanna. Nilesh, Prasanna, both of you raised your hand and you're not talking. Was that by mistake or what? People are not talking now. Okay, fine. Let us configure. Am I audible to you all? Am I audible? Okay, fine. So R1 and R2 are taken care. So now we are heading towards PC1. So PC1. So PC1 is declared with what? PC1 is declared with, I think this is the interface. Okay, this is the interface. So PC1 should be with respect to 10.2. With respect to 10.2, I'll just copy this and I'll paste it in PC. But no IP routing is added. Yes. No IP routing is added. Exactly. So just copy this and add no IP routing accordingly. It's WR. Fine. So show IP route, whether it is changed or not. Yes, it has changed. So it is not popping up with the routing table. So show IP interface brief. Okay. 10.2 is assigned. Good to go. And it is up. And here also in PC, in PC2, the condition is F0 bar 1, but I need to add 30 series. Yes, 30 series need to be added and WR. Exactly. Show IP route. Okay, it is also configured now. Show IP interface. You need to check whenever you are doing it. Please check it. Yesterday I made a mistake, na? Yeah, so please check with show IP interface brief. Okay, everything is up and working. So will I be able to communicate now? Will I be able to communicate?
And say,
No, right?
for PC2, the interface is F0/0, but we consider F0/1.
F0/1.
I think so.
Okay.
And it is also for PC1.
Oh, very good, very good, very good, very good. Thank you, thank you, thank you. Very good. Okay, I'll just configure this. Don't worry, but I'll change the IP address because it will overlap. I'll give 10.3 and here 30.3. It will overlap. Very good. Thanks for reminding. Okay, so this is okay. Then for PC2 also we'll do it. Yes. Thanks a lot. Thanks a lot. Thanks a lot. Okay, I think we are good to go. Yes. So now the default routing same as we did for static routing, but what we do is I'll just create the default routing in R1. So go to global configuration mode, go to global configuration mode. In global configuration mode, IP root, so what is that? 0.0.0 and 0.0.0.0. So what is this? Destination network address and subnet mask of that destination, whichever the IPs we have configured now, that IP, I mean subnet mask, and here give F, which is the exit interface. Tell me the exit interface of that. F0/1, exactly. Thank God you people are reminding me with all the troubleshootings. Good guys, good. Now check show IP root. Check show IP root.
ట్రీట్ చేస్తున్నారు వన్ రిక్వైర్మెంట్ బట్టి వాడు దేనికి యూజ్ చేసుకుంటాడని తెలియదన్నమాట తర్వాత.
Hello brother, who is this? Madhavacharan. Please go mute. Madhavacharan, please go mute. So this is the problem. Whenever I unmute give the permission, this will be the problem. Okay, can you see here guys? Can you see with the static condition, a default condition star is created. Can you see that? Can you see that condition? Yes, exactly. Just try to ping from R1. Just try to ping from R1 to which is that network? 30.30.30.3. Yes. Take some time. .2. 30.2. Only one interface. So that's why it has to work. It happens the same way.
Sir, why we have used 0.0.0.0?
So it is the syntax for default routing. So that is why we have 0.0.0.0.
Okay.
And when R1 is not aware of that route, you can also provide in this way as well. So let us configure this R2 as well. Conf t IP root 0.0.0.0 so which is the exit interface F0/1. F0/1 is the exit interface. Okay, fine. From R1, so what is the address of this one? R1 FA0/0 interface. What is the address? 10 dot. What is the address? Yeah, for PC2 10.0.0.3 or 2. Okay, how many interfaces it is up with? This one. Show IP interface brief. Okay, so it is up with 0 bar 0 and 0 bar 1. Okay, fine. Only one interface we can give because we are not providing the root, right? Okay. Conf t. So to shut down the interface, this is the command. To shut down the interface, this will be the command. Please observe. Interface. I don't want F. So which is that interface? F0 bar 0, right? Okay, F0 bar 1 I don't want. F0 bar 1 I don't want. So shut that interface. Exit. To show IP interface brief. Can you see this interface? It's administratively down now. Can you see this? Yes. To WR. Yes. Okay, I'll just go here as well. I'll do the same thing. Show IP interface brief. Okay, I don't require 0 bar 1 here also. Conf t 0 bar 1 is there. Then interface F0 bar 1. I'll just shut down this. Shut. Exit. To show IP interface brief. Okay, so this is also administratively done. So .3 is working on both the routers. Sorry, on both the end user device. .3 and .3. Okay, in this I'll make some changes. Conf t IP root 0.0.0.0 and 0.0.0.0 F0 bar 0. Exit. Show IP root. Yeah, it's connected now. Now ping 10 dot 30.0.3. Again, it is not taking. So what is the address of R2? 20.0.0.2, right? Getting the replay. Okay, I'm getting the replay for R2. Okay. From R2 to R1. R2 to R1. 10.0.0.3. Okay, let me check with the exit interface how they have taken. 1 second. 0.0.0. Demo of this. No shut. No, I can't assign it again. Wait. Default routes, candidate default is coming. So this value is coming, na? You are able to see this value. Na? Are you able to? Yes, star, you are able to see that. Okay. One second. I'll just check it. Configure default route on which one? F0 bar 0. So which is the exit interface that they have taken? That is what I'm checking. F0 bar 0 is the exit interface. Okay. One second, guys. Show IP route. Yes. If you can see here, the candidate default is also created. Yes, na? The candidate default is also created and it is appearing. For which configuration we did it? Show IP interface brief. So how many addresses are there? 30.1. So let me check whether these systems are able to ping. Once again, are we doing some mistakes? Ping 10.0.0.1. Okay, I'm able to ping here. 30.0.0.2. 2 or 3? Dot 3 or 2? No. Whether it is dot 3 or 2, that is what I'm asking. Dot 3, right? Yeah, dot 3 we gave. Once again, it is starting to reach. Let's say there will be some glitches, so that is the issue. Once again.
Sanjay, hello.
Yes. Hello.
In this topology, it's PC1 and PC2 are supposed to be end users, or is supposed to be routers.
No. It is end user.
Okay. Okay.
Why any confusions?
It is like a simple static routing, right?
No. I'm just showing you how to configure default routing. That's it.
Okay.
Okay. But it has to take, but it is not accepting. Anyways, the root is getting accepted with.
Hello, Sanjay. Hello. Hello, Sanjay.
Hello.
Hello.
Yes, please tell
Hello,
me.
Sanjay.
Yes.
The syntax will be same always. Only that exit interface will be changed.
That exit interface, that is what? I think we gave that exit interface also proper. See, for R2, that exit interface will be F0 bar 1. Okay.
And
for
our end users, we right now we have 3, right? PC1, PC2, and PC3.
No. We got 2 end users.
Okay.
We got only 2 end users. That is what I was looking. Why it is not pinging? Because it is trying to ping. For example, R1 is able to ping. R2 is able to ping. Once again, I'll check it. R2, it will be able to ping 10.0.0.1. I think it will be able to ping it.
Hello, Sanjay sir.
Yes.
Hello sir. Actually, that exit interface is there, no sir. You have given as a F0/0. You need to edit that. Actually, it should be F.
No. Please tell me from scratch which router you are talking. Did I made a mistake?
Yes sir.
Yes. What is that? Please tell me.
Can you check that one once?
For R1, okay, like, okay, fine. Did I make a mistake? That was I was checking. Conf T, then
Yes, it
IP
should
root,
be,
na?
yes,
IP root,
it should be 0/1, sir.
it should be 0/1. That is one I gave, right?
No, sir.
F0 bar 1, na?
Yes.
F0 bar 1. Yeah, this is what I gave. This is what I gave, no? Okay. Let me check. Show IP root.
Earlier you have given 0/0.
No, it's coming. The default candidate is coming now. Yes. I'll just check it. Okay.
Yes.
For R2 I gave or what?
No, sir, here you can see, sir, 20.0.0/8 is directly connected to fast Ethernet 0/0. Here you can see, sir, it should be 0/1, right?
Once again. Okay. I'm configuring with R2. Can you please help me out now? If I made a mistake?
Yes, IP root.
IP root, yes.
0.0.0.
Yes.
And F 0/1.
F0/1 with respect to this network, right?
Yes, sir. Exit interface.
Exit interface. Yeah, that is what I gave, no?
No, earlier you have given 0/0.
Is it? Okay, let me check. I don't think so. I gave that.
No, sir. Give, sir. You gave.
I gave it. Okay, fine. No,
Yes,
no. Fine. One second. I'll just ping it. Okay. Ping.
Okay.
So what is the address of PC2? I'm pinging from PC1 now. What is the address of PC2? Is it 30.0.0.3 or 2?
2 or 3. Okay.
Let me check. See, for simple configuration, so there will be a lot of minute mistakes. That is why I always carry in Notepad, but few of them they asked me for doing the things in the terminal itself, so I did it. They are leaving in the chat box.
Sir, the issue is that while configuring, you have just missed that end user devices. You made the mistake over there, that 0/1. That's why all things we need to change. We have changed IP later, na? So that's why it creates lots of confusion.
So do you want me to change this? No, I'm asking you, do you want me to change that?
No, sir, that is not the issue. But the thing is that we have changed many things later on. Na? After configuration, we have edited many things. So we are getting confused over there that which is the IP. We have changed 0.3 later on. So that's the thing.
0.3. Okay, fine. I'll just configure it. 1 second. Give me a moment. So this will be.
Sanjay,
Yes.
can we write the IPs of the nodes IPs of the interface node? Let's write along the diagram, along the topology, so we won't be confusing. It won't be confusing for everyone.
Okay, for PC1, I'll dedicate. Okay, I'll dedicate 10.0.0.2. Is that clear?
Okay.
Okay, for PC2, I'll dedicate 30.0.0.2. Is that clear? For R1, that is R1, F0 bar 1, I'll dedicate it for 10.0.0.1. For R2, I'll dedicate for R1 itself, I'll take. For R1, there is one more interface, na? R1, I'll dedicate F0 bar 0, and I'll dedicate this as 20.0.0.1. So let us come to R2, which is having two interfaces. So among that, F0 bar 1 will be So what is the address I gave there, guys? 30.1 for R2. Fine. F0 bar 0 is also there.
Sir, that is 20.2 na?
Which one?
F0/0 for R2. R2 F0/0.
Which one? R2 F0 bar 1 is here, na?
R2's F0/0 20. Yes, 20.0.0.2.
Exactly, na? This is the
Yes.
one. Okay. So fine, I'll go to PC1. Anyways, routers are configured already. I'll go to PC1. Conf T interface F0 bar 0. Fine. Okay, before that, exit this once again. And I'll just give no IP routing. No IP routing. And I'll just come with interface F0 bar 0. IP add 10.10.0.2. For PC1, it is 255.0.0.0. So no shut and WR and WR. So show IP interface brief. Is it fine now? Anyone can talk. Is it fine now? Yes.
Yes, sir, it is fine now.
Yes. Okay, I'll just go to here and I'll just check with conf T interface, sorry, no IP routing, interface F0 bar 0, IP add 30.0.0.2, 255.0.0.0, then no shut.
Sir, for R1, why no IP routing? R1 is router na? It is not end user device.
Which one?
R1.
R1 I have not configured anything. It is PC2 I'm configuring now.
Okay.
Don't get confused. Okay. PC2 I'm configuring now. Show IP root. This is the device a device as an end user device. It's not showing the routing table. Show IP interface brief. Fine. So it is configured, right?
Yes.
So this is end user devices. So this will
Yes.
be PC1 and this will be PC2. Okay.
Can you show the IP address of PC1?
IP address of PC1.
I mean brief. Yes.
The same, na?
Okay, it's good.
Same address.
Yes, sir.
The same address I have configured. You can also check here. 30.0.2 na? I configured here. Where is that? PC2, yes. It's here. Can you see? The same IP address. Okay. So let us go to R1. R1, I think it is refreshing now. Okay. Conf T. Show. Let us check. Show IP interface brief. Okay. 10.1. Fine. It's up and running. IP root 0.0.0. 0.0.0. What will be the exit interface?
It's 10.2,
0/1. 0/1.
It's 0.2, right? The IP address would be.
Which one?
For PC1, for configuring the IP address, it's considered is for.
I'm configuring with R1. Don't get confused.
Okay.
I'm
Correct,
configuring
sir.
with R1.
Okay.
R1 is 10.0.0.1, right?
Yes.
Sahi hai.
Okay.
IP root 0.0.0. Then
F0/1.
It's
F0/1 na? Exit. Show IP root. Okay. So this is the default candidate. Okay. And it is popping here. Can you see this? Are you able to see that? Yes.
Yes, sir.
Yes. It's a default candidate. Okay. It is created. And the same thing I'll create on R2 as well.
For R2. Yes.
Conf T interface F0, sorry, I'll check with the IP address whether it is there or not first. Interface brief, show IP interface brief. Okay, fine, it is up and running.
Correct.
So IP root 0.0.0, then 0. So which is the next one? 0.0.0. Then what is the exit interface, guys?
Show port once. 0/1 है क्या? Yes, 0/1.
Okay, I've given absolutely fine with all the. Okay, let me find the immediate PC whether it is interacting or not. Okay, is it interacting?
Yes, sir.
It's interacting. So let me check with R1 interface address. R1 interface address is this na 20.0.0.1. Let me check that as well. Okay, it's interacting. Okay, show IP root. Okay, everything is connected. Okay, the default candidate also has been added for this route. Fine, it is working. So let us ping from R2 to PC1. PC1 what is
0.0.0.2.
My question is why it is not pinging?
Yes, sir. It should.
It has to ping. Okay. Moment, guys. Wait, this DNS has got many issues. Okay. I think this interface, I think so. The exit interface, it's troubling. I need to check with the syntax whether it is appropriate or not. Let me check with the syntax. For the syntax we have taken. Exactly the same thing we are doing, na? Yeah. The same thing we are doing. Okay. Show, I mean, IP routing to show IP route. Okay, it's coming. Is it deleted? The default is deleted now. The default route is deleted. Once again.
How it is deleted, sir? But
no, I gave no IP routing na.
Yes. Okay, that command.
It will delete. Okay, it will delete. Only it will show the show IP route. Let me check. No, not this one.
IP route only.
0.0.0, 0.0.0. Then I'll just leave F0 per 0. Let me check this as well. Or else shall we give the next top IP? Else I'll give F0 per 0 itself. Exit, it is taking, it's accepting. Show IP route. Okay, it is taking for everything, na?
Yes.
For everything is taking. How come? How come it is taking for everything?
But sir, that is not exit interface.
Yes. That is what for everything it is taking. Show
And sir,
IP. One second. Shall we check with IP route 0.0.0, 0.0.0? I'll just check with next top IP now 20.0.0.2. How come for everything it is taking? I'm wondering now. Show IP route. Okay. So the AD value is 1, na?
Yes.
The AD value is 1. Okay, I think let us give next hop IP. It is not taking the exit interface. Show, sorry. Conf T IP root. Yeah, for R2 I'm configuring now. Yeah, 1 second. For R2 I'm configuring now. 0.0.0 and which is the
20.0.0.1.
1 exactly. Exit to show IP root. Sorry, I'm in the privilege mode.
Only SH.
Okay. Now it is giving some other na. Via it is giving now.
Yes.
Okay, let me check my PC1 now. What was the address we pinged? Can you please tell me the address? 30.0.2 from PC1.
From PC1, yes. Will fail, sir.
I think it will not reach out.
If it takes time, then it definitely going to be fail. Maybe.
Yeah, if it is there is a delay and we have to give some permissible time for that.
But sir, this default case we use whenever there are multiple multiple networks, no? Then instead of static routing, we are using default.
Yes.
But sir, the issue is that we are not providing the destination and subnet mask, and we are direct providing the exit interface. Then how it will come to know that which router's exit interface is that?
But with the previous entry of the routing table, by the immediate neighbors, it will come to know. See, the immediate neighbors are these two guys, na?
Yes, as here only means this is a very simple case. Here are only 2 routers, so it will take immediate neighbor. But for multiple routers, also it takes a neighbor, immediate neighbor.
From one second. From R2, it is taking. Can you see that?
Yes.
R2, the network is able to reach out. 1 second. From PC2, let me check. Yeah, I'll give you the break. Don't worry. I'll give you the break till 11:30 now. I need to check with this glitch. See, from when R2 is trying to correspond, even PC2 to PC1 should be correspondent. But I don't know why it is not taking. Let me check.
Is there any direct connection loss? Can we check for that?
No, I'll check from R1 because R1 is isolated from this network, na? This 30 dot network, it is isolated, na? I'll just check from R1. So if R1 is working, it is also it should also work. So I'm pinging PC2. From R1, I'm pinging PC2. Once again, I'll just check it.
125.
ఇదే
ఇంత తక్కువ తెలుసా ఊబర్ ఓలా ఇంకో 2 ఉంటాయి అందులో చూస్తే 190 200 ఇస్తుంది
See, can you see there some delay is there, na?
అదే వేరే దాంట్లో మమ్మీ దాంట్లో తక్కువ
Some delay is there. Wait. Some delay is there. I think some technical glitches are there. So that is why it is not corresponding. Okay. Fine. Do one thing. Take a break. We'll solve with one more network. Okay. I'll just refresh this.
Sir, 40% is okay, na? Means
40% is okay, but I need to get. There is a lot of delay in the network.
Yesterday also, sir, it same happens with me.
No.
Means
See. Once it is 40%, and in the next ping, if it is coming 100%, then it is fine. No issues
sir,
at all.
for me, 8 to 10 times I have done, but only 40% was there. Then I again reconfigure that particular router, then it will show 100.
That router, it will take some delay. See, something like this, it will be coming always.
Yes.
I'll wait for. Let us take the break and let us ping it back. See,
Yes.
Can you see this? It is very discreet.
Yes.
The delay is very discrete, na? It is not continuous. Yes, the delay is very discrete. Take the break till 11:40.
Yes.
Take the break till 11:40. I'll come back to you people. So there is a delay. Okay, just check it.
What?
కూడా ఎక్సెల్ ఎక్కువ పుట్టిన తీసి అంటే అంటే మొత్తం కాదు మొత్తం మంచి మంచిగా ఉంటాయి మెయిన్లీ అవి ఉంచుకున్నాం దేనికి ఒత్తి పట్టుకొని మాట్లాడి వదిలేయాలి అయిపోయినాక ఇంకా తీసేస్తుంది
Yes, guys, am I audible to you all? Welcome back.
Yes, sir. बोलू था मैं.
Yes. Thank you. Fine. See, guys, I've reconfigured that. The issue was it was not taking. There was a server issue as well, server connectivity issue with the loopback address as well with GNS3 tool, and I restarted it and I configured the same topology again. Okay. Is this the same topology that we configured?
Yes, sir.
Is the same topology, right? Yes. So this was 10 network and this was 30 network and this was 20 network. Right? So what I did was I just gave, let us not kill the time on this now. I just gave, for example, in R1, I gave the next hop IP rather than interface. Is that clear? In R1, while giving the default route configuration, while providing the default route configuration, I provided the next hop IP rather than the exit interface. Is that clear?
But, guys? That next hop IP is 0.2. It should be 0.21, no? 0.2.
So it is 0.2.
Yes,
it is this interface. I'm talking about this interface. Exactly. I'm talking about this interface now. So this interface gives the next hop IP. Please, make a note that you will consider only next hop IP because there will be a lot of technical glitches with exit interfaces. Okay, so always consider the next hop IP because whenever the IP address is been up and running, right? So logically it will be connected to the router's interface itself. So in that case, it will give you the exactness.
Sir, yes, that what I have asked previously, that if there are multiple routers, then how it will be configured that this exit interface of this particular router. That's why this next hop IP is means it is a clear scenario that it belongs
that is
to.
so always it is a good practice. Yesterday also I said, right, rather than using the exit interface, always it's a good practice to have next hop IP itself. Okay,
Yes.
because it will give the complete clear picture of it. So I did the same thing for R1. I'm showing the figures of R1 now. Is that clear? I'm showing the figures of R1. I'll just show you the figures of R1 routing table also pop up with. Can you see this? The default route with AD value 1, by default AD value 1, and also it is taking via which route it has to reach the destination. Is that clear? Which route it has to reach the destination, it is giving the clearness. And again, for R2 also I gave the same thing. Can you see this? The next hop IP is R1's interface, right? So I gave the same interface. It is working now. And I'll just ping from PC1 to PC2. PC1 to PC2. Can you see? So this is PC1 address. Okay, let me check, show you the PC2's address. Okay, one second. And show IP interface brief. So can you see this? PC2's IP address is this. So when I'm trying to ping from PC1 to PC2, the 30.0.0.1, it should be acceptable. Can you see this? Is the picture is clear now? So there was few glitches. I have solved those glitches. You can solve according. No issues. Okay. So this
for PC2 it is 30.0.0.2 na?
No. I changed it. I changed the complete scenario. I renamed the project itself. I renamed the complete project and I started from scratch.
Sir, but
There was error.
Then R2Z0/1's IP, what is the IP address of R2Z0/1?
0/1. One second. Show IP interface brief. Yeah, it should be 30.0.2.
Means okay, you have given the down up.
I've changed it completely. I've changed it. I reconfigured the structure.
Okay.
Okay. So this gives the clarity of the default routing. So it killed our time because due to this glitches. Okay.
Yes.
So from wherever to where, from end-to-end connectivity, you can ping. From R2 also, if you are pinging PC1, it should accept 10.0.0.1. One second. It's accepting. Okay. There is no delay. There is no delay as of now. Okay. Yes. Please go ahead with your question.
And sir, if suppose now multiple routers are connected, then no need to do this thing again, na? Because we are doing default routing.
Yes, no need to provide the static routing, but static routing by default it will give the administrative value. Even though if it is not a static routing, can you see that output of it? I mean, in the routing table, can you see this? Along with the static route, it's a static route. Static means what? It remains the same. It will never change. It will never change. The route will never change. Fine.
Yes.
So in this route, by default, one signifies what? Static route itself, right? It is the AD value of static route.
Yes.
So it is providing the static route itself, but it is taking the default condition. That's it. Rather than providing each and every destination network address of that route. So what we are given? Entirely we have created the zero marking. That's it.
Sir, then if such scenarios come in future, then what will we should use? Static routing or default routing?
It will be asked. It will be asked to you. Which are the routers that need to be configured for default routing and which are the routers that need to be configured for static?
Okay. Fine, sir.
Sir,
Yes. Am I audible to you?
Hello, Sanjay.
Yes, yes. Am I audible?
Can you? Hi, yes, you are audible.
Yes.
Can we ping R2 from PC1?
R2 from PC1. Okay. So which is the address you want to ping?
No, I'm just asking general one.
Yeah, we can ping. We can ping. See, let me check. So what is R2's address? 30.0.2, na?
Yes.
No. Yeah, 30.0.2 is the R2's address. One second. Let me check R2. What is R2's address? Yes, 30.0.2. Okay. Are you able to see that, Adinath?
Yes.
Yes. You can ping from any end. From any end, you can ping. You can check the status. No issues.
And in previous static case, it is not possible, I think, or possible.
Yeah, it is possible. It is possible. I show all the scenarios now. From all the devices, I try to ping.
Okay.
It is possible. It is possible. Even from R1 also, you will be able to. I mean, from PC2, you'll be able to ping R1 as well. I'll just show you that. Ping 10.0.0.2. See, it's taking. Even for PC1 also, it is taking. Are you getting it?
Yes. Thank you.
Yes. Okay. I think we are good to go with the next dynamic routing. But before dynamic routing, I'll tell you how to work out on this, and you can work on this scenario of configuring the default route and static route. It's there in your legs. Okay. And also you can go through the videos by the knowledge I have given you, so you can act accordingly. See, configure the following topology with appropriate IP address and establish end-to-end connectivity using static routing. Is that clear? Using static routing. So for which are the devices that need to be enabled for static routing? Tell me now. By looking into this architecture, which are the devices that need to be enabled for static routing? Which are the devices? Okay, let me treat something like this. For R1, R4 is the destination. For R1, R4 is the destination. So which are, or for example, R4 is the source and R5 is the destination. R4 is the source and R5 is the destination. R2 is what? Are we supposed to consider R2 for this one? So don't treat any inducer devices here. Treat everything as a router now. All are routers. Don't treat any of the devices as end user device. Treat all the devices as routers. Are you able to see my screen? Yes. So here in all the routers, I'll treat something like this. From R4 should ping R5. R4 should ping R5, for example. So which are the networks that are that need to be configured for static routing? On which routers? On which routers we need to configure the static routing now? Yes. So 172. So you should ignore the directly connected networks and you should only configure the destination networks. That's it. You should only configure the destination network. So 172 should be configured. Yes, right? 172 should be configured. Yes or no? 172, it's a different network. And again, it's a different network. See here, 172.16.10.0, 20.0. It's a different network. Fine. At R2, on R2, which are the networks that need to be configured for static route? On R2, so that is one is this network and the other one is 10.0.0. network. Exactly. I think you are good to go with the connectivities, right? And there is a condition, note, implement default routing only on router 4 and router 5. That's it. So you need to configure the default routing only on router 4 and router 5. You can check the scenario and you can try out with this. I'll give you sample amount of time. You can try out with this. Is that clear?
Sir,
yes.
Wait a minute. Sir, if we have to reach from router 2 to router 5, Then we have to make connections for two networks, na? 172.16.10.0 and 10.0.0.
Yes, exactly.
Then we have to do static routing 2 times, right?
Yes, you have to do 2 times. Exactly.
And also vice versa.
Yes,
From
vice
5
versa.
to 5.
Yes. So R1 is mutual for both the sides.
Yes.
R1 is mutual for both the side. Is that clear? So there are 1, 2, 3, 4 networks. 4 networks are there. 4 divided by 2. On each router, when you are implementing the static route, it will be two routes. Is that clear?
Yes.
Yes, that's it.
And route for 4 and 5, it should be default routing. Means
Yes.
only one time.
Yes, it's only one time for router 4 and router 5.
Okay.
Can you explain it one more again?
Yes. See, this is your exercise problem. Is that clear? This is your exercise problem. So when you want to configure this route, so here there are total number of network addresses are what? 1, 2, 3, and 4, right? 4 number of network addresses. So 4 different network addresses are there. For example, I want to ping from R4 to R5. So which are the routers that will involve in static routing now? Which are the routers which will involve in static routing now?
2 and 3.
2 and 3 should get involved, right? Because R1 is mutual for everyone. R1 is mutual for 2 and 3. So you need not to implement for R1. So you can implement on R2 and R3. Is that clear? You can implement the routing static routing on R2 and R3. So for R2 and R3,
R1 doesn't need the static routing.
R1 doesn't need
Static routing, right?
R1 doesn't need any static routing because R2 and R3 is there, right?
Okay.
When you configure R2 and R3 will update its routing table, na?
Okay.
And also it will give it to R1.
Okay.
Fine. You can configure this. And for default routing, you have to configure only for R4 and R5. That's it.
Okay.
So which is the exit interface you will consider for R4 while configuring, the next hop IP? So this should be the next hop IP. Is that clear? For R4, this F0/0's IP address will be the next hop IP. And for R5, F0/1 IP address will be the next hop IP.
Yes.
Hello.
Yes.
If any router fall in middle, so no need to do static routing, right?
What?
If any router fall in the middle.
In middle?
Yeah, in the
Sir, he is talking about router 1.
Router 1, right?
Router 1, yes.
So can you please explain another scenario?
Yes, please go ahead.
Explain another scenario where we no need to do static routing.
See, this is a simple network. How many LANs are there here? Tell me. How many local areas are there? Is it 2 or 4? So there are 4 LANs, right? There are 4 LANs, exactly. 4 different network address means 4 different LANs are there, right? As I already said, whichever the devices which are connected, they should be completely mutual for only one network address. So according to the scenario, we got 4 LANs are there, right? So on these 4 LANs, so we need to think how many number of connected immediate neighbors are there. So which are the immediate neighbors for R2?
R4 and R1.
R4 and R1, exactly, right? So R2 is completely isolated from R3, right?
Yes.
Yes, R2 should be knowing the exact network address of 172 and 10, right? Yes or no? Even 10 is completely remote for R2 and also 172 is completely remote for R2. Yes or no? Yes. Whenever you try to reach this network, you will not be able to reach. So that is why we need to construct a static route.
Sir, then for this R2 router, F0/0 of router 1 will be the next exit interface. Na?
Which one? For which one?
If you are making static routing for router 2 for reaching 172.16. Point 10. Then the exit interface will be F0/0 na, of router 1. F0/1.
F0/1 will be the exit interface. Exactly.
Yes. Okay.
Exactly. When you are looking for this destination network, F0/1 will be the exit network. Yeah, exit interface.
Of router 3.
Yes, of router 3. Yes, exactly.
Sir, we have to do it right now or later?
No. You can take your time. I'll just give the explanation of dynamic routing.
Okay.
Okay, let us brief out where is the advantages and disadvantages. You got many tryouts here. You can try it. Okay. See guys, advantages and disadvantages of static routing. Tell me whether we witnessed or not. Okay. Advantages of static routing: simple to configure in relatively smaller topology. Yes or no? Agreed? Yes. Route is predictable, right? We can guess the routes. We can guess the routes through the interfaces as the routing entry does not change automatically. Yes or no? Yes or no? Yes. For example, difficult to configure as network grows. Yes or no? Because what is the limitation? Maximum number of 4 networks, right? As the network grows, we will not be able to configure the static routing as it gets expanded. So it is not the scenario that one building will be having, one campus will be having only one sort of network, right? It need to get grown up. Yes or no? It need to get grown up. So in that kind of situation, we'll not be able to simulate with this static routing. It is completely impossible with static routing. Even also default routing also it will get failed, because default routing is it is a concerned level of static routing itself, because the path is predictable in default routing as well. So it can't take, and also it will lead to lack of security. These kind of criterions will lead to lack of security. Is that clear? Because when we are providing the default route, okay fine, as a network administrator, I'll be providing the default route. So what happens? Even though if I'm interested in those routers or not, I have to pass through that routers itself, right? We can't restrict. Yes or no? We can't restrict the network. Yes. Will you be able to tolerate if any of the number of traffic is getting allowed into your network? No, right? So there should be some restrictions that need to take place in the network traffic, right? So it is highly impossible in static routing or default routing. So now next one is backup paths cannot be configured. Yes or no? The backup paths, because the route is being predetermined. The route is being predetermined. So it is only suitable for smaller networks. As the expand goes, you can't take up the backup path, right? Because it is limited only for maximum up to 4 networks. You can't consider for, yes, possible in default. Possible in default in which scenario? Chetan. Possible in default in which scenario you are talking about? No. When there are connectivity between those paths, you will not be able to take up the backup at all. How you are going to take up the backup of the configuration? It is not highly impossible in static routing, and traffic cannot be routed automatically, right? If a static route fails, yes or no? You have seen this this route, right? Well, for example, you have seen this topology as of now, right? You saw this topology. So there was complete traffic which was going only with this route, right? Just think of if any of the router fails. If any of the router fails, what happens? Even the backup will be lost. Even the backup will be lost, and the entire topology will get down. Yes or no? Yes, the entire topology will get down. So that is the highly other condition where we can come across with static route. And also one more condition is there. The static route will not entertain the cyclic graph. It will not entertain the cyclic graph. So what is cyclic graph? It's something like this on the clockwise. It will not enter time. So once the route is created, so there should not be any disturbance for the routers which have created the static route. So if it is getting too many number of traffic, it will not be able to allow the traffic on that route automatically. So that is one of the major disadvantage of static route. Is that clear, guys? Is that clear to everyone? Am I audible? The entire topology will become down, exactly. Okay, so anyways, we saw this. Please go with the tryouts of static route, how to build it with respect to this tryout, and you can work out on it. And we got the troubleshooting issues. The first issue is with respect to the connectivity issue. So everything has been given in the flowchart. You can just come across with the connectivity issue. And again, exit interface issue. So we have seen a couple of things that happen in exit interface issue, right? So you can also come across with this issue as well. And next hop address issue. Next hop address is nothing but next hop IP. So what are the issues that we will find? I'll just go with this because be very friendly enough with this kind of structure so that it will be helpful for your troubleshooting aspects as well. Okay. So now communication issues between source and destination. So we saw that from PC1 to PC2. So what are the issues that we can come across with if the static route is not being configured? Yes or no? If the default route is not being configured. Now, when you click on show IP route should result with what? Static status, na? It should result with static status. So it should give the property of via, right? It should give the property of via. Do you agree? Do you agree with this? Yes, it should give the property of via. Now, what happens here is the route. So we are making a decision here. Is the route present in the routing table or not? Yes or no? If the route is not present, what happens? Packet filtering. Yes, right. If the route is not present there, the packet filtering take place. Immediately the router will drop down the packet so that it will not allow for its further transaction at all. So what happens? If it is not there, create the static route. You have to create the static route. So for that entry, again go and check with the status and create the static route status. So you will come to know. So are you not aware of this command now? I'll just give this command as well. Show IP route static. See, it gives only, rather than giving all the connected scenarios, it will give only one table. Is that clear? Yes, only static scenario will be presented here. If you provide after show IP route static, if you provide, it will give only the table of the static behavior on that topology. You can check out when you are going to try it out. Fine. Yes. Next. So next hop IP address, yes, that is what his route is created with correct next hop IP address or not. So what should be that? What is that? Next hop IP is nothing but the neighboring router's immediate IP address should be given with respect to that interface. Then you can check with the command. So what is that command? Configure IP address in the same subnet. It should be in the same subnet address. So if you are giving /24 and if you are looking for that address in a different subnet, it will not work out. So that successful communication between source and destination will happen. If the same address, same IP address of that network is given and also the subnet address is given, so you will be able to communicate from source to destination. Am I audible, guys? Am I audible to you all? Yes. So this is the scenario. And I think we are good to go with summary of static route. So building routing table manually. Yes, na? We built the routing table manually, right? Yes. Verifying the routing table, we did it So what was the parameters that we involved? One was checking up with what? Destination network address. One destination network address. Then we checked with AD value, and also we checked with which is the route that is being able to reach from there, and also we checked with the status of static default routing, and again advantages and disadvantages we have addressed. What is the AD value? Default AD value for both static route and default route, it is 1. Can we manipulate or not? Can we manipulate the AD value? Yes, we can manipulate the AD value. What is the maximum figures that we can manipulate? 0 to 255. Exactly. 0 to 255 is the maximum manipulation that we can come across with. Okay. The next one is dynamic routing. To overcome the disadvantage of static routing, because there won't be any feasible backup paths, there won't be any relativities of connectivity that can happen dynamically. So, right? So, if we configure the dynamic route, everything will be handled on an optimal way. Can you see it is completely cyclic now? It is completely cyclic. Can you see this dynamic routing topology? It's completely cyclic, and it is supporting both cyclic and acyclic scenarios. Both cyclic and acyclic scenarios. If you can see this topology here. Okay. So now first thing what we need to do is, what are the protocols? Yes. Are you able to view this? Yes. See, for your hands-on, most probably RIP will not be there. RIP will not be there for your hands-on, that is for sure. But without RIP, I can give the explanation of OSPF or EIGRP. Is that clear? So to cover this OSPF and EIGRP, you should be having the knowledge of RIP. Clear? And this AD value is 120. And the AD value is 120. Is that clear? And the AD value of RIP is 120. Now, it is used to exchange. So there are two differentiations here. One is interior gateway protocol, and the other one is exterior gateway protocol. So for your lookups, for your course content, you will be studying only with interior gateway protocols. Is that clear, guys? Interior gateway protocols, which is subjected to one autonomous system. Interior gateway protocol always is subjected to one autonomous system. When two number of autonomous system of different conditions want to interact for interactivity, then we will go with exterior gateway protocol. Is it clear? Yes, people, am I audible to you? Yes. No sign of, okay, fine. I don't know what you people are doing. No sign. What were you doing, Zaid? See.
Sir, can you please tell again IGP and EGP?
Yes. Interior gateway protocol, it belongs to one autonomous system. What is autonomous?
Which has its own right.
Yeah, which have got independent decisions, right? The decisions won't be dependent, which will have independent decisions. It's something like your private universities, right? It's something like private university, which has got complete independent. It can take its own decisions based on its scenario. Based on its scenario, it can take the decisions. So it is used to exchange routing information between routers within an autonomous system. So it is completely an intra exchange. It is completely an intra exchange. So better example is your Infosys campus. It is one autonomous system. So there are different divisions, right? HR, finance. So many scenarios are there, right? So each and every department will be configured with one LAN or single LAN. So there will be different LANs, right? Intra LANs that need to get communicated and which will connect. So the whole system is called as autonomous system. It belongs to one entity, right? Autonomous system always belongs to one entity. Clear? Am I audible to you? Yes. So likewise, in this autonomous system, we'll be handling with routing information protocol, which is where the ID value is 120. For OSPF, it is 110, and for EIGRP, it is 90 AD value. So which is having the least value? Which is having the least value? EIGRP is having the least value, right? We'll come to know what is the advantage of having this least value in EIGRP. Is that clear, guys? Is it clear? Fast? No. Talking about the scenarios, if the chapters are very fresh to you, so that you are feeling fast. Okay, I'm going very slow. Yeah, where exchange of routing information happens between the routers within the site. Within the site is nothing but within an organization. No, minimal value. I'm talking about minimal value. Minimal value gives the optimal result. So that is what I'm talking about. With respect to the path selection, EIGRP, when compared to these two protocols, EIGRP is the best protocol. So that is what I said. 90 is fast, of course. The reachability between source and destination.
Sir, we can take it as a kilometers. That is 90 kilometers is lesser route.
No. It is not something like that. We need to calculate the efficiency here. It is about efficiency.
Sir, what is that term? AD distance, how it is calculated?
Which one? By default, it will calculate. It is a default. It's a default structure which has been assigned by Cisco.
That 90 is the shortest path, no?
No, it is not shortest path. Please see, AD is not a nomenclature of shortest path. AD is an administrative distance. What is administrative distance? For example, okay, let me completely tell you like this. Have you heard about convergence?
Yes.
Term called convergence.
Yes.
What do you mean by convergence? Have you seen a scenario called bird's flock? Have you seen a scenario called bird's flock? In the evening, all the birds will be aligned together. Have you seen that?
Yes.
Have you seen that?
Yes, sir.
Yes. So it is called as master and slave scenario, or leader and follower scenario.
Yes, sir.
So convergence, there will be some sort of convergence time that occurs. So this AD value will always be related to that convergence time. So this convergence is completely based on one master routing scenario. So each and every routers or each and every nodes which are they existing on that network should be completely aligned. The calculation of that alignment is nothing but the AD value.
Okay.
Is that clear?
Yes.
The calculation of that scenario is nothing but the AD value. So this administration value differs from one protocol to other protocol. It is something like over the efficiency. We will margin it over the efficiency of the reachability. Is that clear? Yes. So these are the three protocols that we will be studying in dynamic routing as of your curriculum. So border gateway protocol is there. Again, it is distinguished into interior and exterior gateway. So no need of dealing with this protocol as per your syllabus. Exterior gateway protocol, so it is not there. You can mark it. Exterior gateway protocol, it is not there for your syllabus. You can mark it. For your training syllabus, it is not there. Okay. Okay. Just go with this explanation. Yes. What is RIP? Routing information. For example, now I am new to a city. New to city. So now think that today we got better convergence of Google Maps. Okay, fine. Don't think about Google Maps. Don't think about Google Maps. Tell me, in the earlier days, how was the scenario? I'm new to the city now. Tell me how a person should get to know that city when he is new to the city. Tell me now. Asking people, right? Yes, asking people with relative paths. Exactly right. Ask the people. So that was the scenario. No, I'm talking. I'm not in this era now. I'm just shifting myself back to 20 years older. 20 years older. I'm new to the city now. So 1845 के बाद, yeah. वही तो, yes. I'm new to the city. Yes. What is that? What can be done? Yeah, just ping me. What are the scenarios? Asking the people. Okay, then he asks about the people. Yes, asking the people is the only way, right? So once you ask the people, is the scenario is completed? Is the objective is completed after asking the people? The people will tell which area to go, how, right? You need to step in, right? We have to follow that principle. So to follow that principle, so you'll be having bus communication, you'll be having an auto communication, or you'll be having some other communication mode. Think that. Fine. In bus communication, you need to identify the route, right? For example, it is a bigger city. Route 1, route 2, route 3, route 4 buses are there. So you should be very optimal enough to choose this route, right? Yes or no? You should be very optimal enough to choose this route. But also, you should be having an idea. For example, this bus goes to area A and area B, which are very neighbor. Is that clear? Area A and area B. This bus goes here. Is that clear? Now, your destination is area A. Your destination is area A, which is led by bus number 1. Now, bus number 2 also goes to this area. Bus number 2 goes to this area B, but your destination is not area B. Of course, this bus misses to you. This bus misses to you. Route number 1 bus misses to you, and you need to urgently follow this route now, right? So which is the route? Immediate neighboring areas route you will take, right? Yes or no? You will take the so that you should be having in your routing table whichever with networks which are attached to that particular router, every entry should be happened in that area. Is that clear? So that my conclusion is the router, whichever the routes which are connected to it, it may be n number of routes, all the route entry should be happened inside the routing table. All the entry should be happened at the routing table. Is that clear, guys? Is the scenario is clear? So that is why we require routing information. The name itself indicates routing information protocol. This complete routing information will be provided so that the source will come to know, okay, fine, if this route is not available, okay, fine, I can route myself over this route automatically. So what is dynamic? I gave the term, right? Automatically, right? Static route was not able to satisfy this condition, but in dynamic route we are able to satisfy this condition. Yes or no? Got it? Got the scenario? Why we are heading towards dynamic routing? To overcome the problems that are existing in static route. So did we achieve the backup here? Yes. Did we achieve the automaticity of this? Yes or no? The router will get automatically updated and it will reach the network, right? The nearest network to reach the source or destination. Yes or no? So this is the condition. We need dynamic routing. In dynamic routing, RIP is an interior gateway protocol which will act only within the autonomous system. Is that clear, guys? Which will act. It means if one failed, try other way. Try other way. So that is what? Try other way. But only one drawback is it uses UDP as a leader. So what is UDP? The path is not defined. The path is not defined. So even though you know area A can be reached from route number 1, bus route number 1, you are selecting route number 2. Okay, fine. Will let me wait for a while and will let me go. Right? So RIP is always dependent on connectionless property. Undefined path. UDP is undefined path, right? It is connectionless. Now you are coming to know what is the appropriate things that we are looking for UDP and TCP, right? Where it is applying. Yes, na? Connectionless approach. It is a connectionless approach. Exactly. Once again. Static is not TCP. No. Static is not TCP at all. Static you can't. It's a unicasting. That's it. It doesn't uses any TCP knowledge. It doesn't uses any TCP knowledge there. If it is using TCP knowledge, then it should be very intelligent routing algorithm. So starting routing, it will become by default. It will become intelligent. Yes. Have you heard about this term distance vector? Have you ever heard about this term distance vector? No, right? No. So once, for example, node A is here, node B is here, node C is here, node D is here. So what happens here is always the cost calculation will take place. The cost calculation will take place. So now tell me, for A to reach C, which is the possible path it has to reach? For A to reach C, it is not directly connected. So what I do is I'll mark it as infinity. It is not directly connected. Distance vector always speaks about directly connected issues at all. That's all. Is that clear? Directly connected issues. So when it is not immediately reachable, so I'll say that A is not reachable from C. So I'll mark it as infinity. So again for C also I'll mark it as infinity. But who are mutual for A and C? B and D, right? B and D. So they are the immediate communicators, right? So based on these immediate communicators, A will be having the knowledge of C now. A will be having the knowledge of C with respect to B's table and also D table. So what happens? This count to infinity problem will get erased, right? Yes or no? This count to infinity problem will get erased so that A will be having a certain route to reach C. Vice versa, C will be also having the certain route to reach A. Is that clear? Is the concept is clear? Yes. See here, this protocol works on the principle of distance and direction. So what is the total distance and what is the direction? So between A and C, it was infinity. Can you say the infinity as a distance? Yes, of course we can say it, right? It is completely remote and we don't know the distance. In RIP, the router will not have the information about the entire network. A was not having the information about the entire network, but only information known to each router is the distance, right? The total number of hops. So A was knowing to reach C, either it has to reach B as one hop or either it has to reach D as one hop. Yes or no? Yes or no, guys? Yes. To reach this destination and exit interface through which the packets have to be forwarded. So it is A's duty that, okay, fine, whether to choose this path or whether to choose this path. Is that clear? So what are the attributes? RIP is a distance vector routing protocol. So you came across with these terms, right? Distance and direction. Are you familiar with this now? Distance and direction? Yes. So distance is calculated based on hop count. To reach from A to C, how many hops A need to evaluate with? How many hops? Only one hop, right? Yes. No, not two hops. Only one at a time. Only one hop, right? So that was B. So here also there is a limitation, that is hop count is the metric. Can I say it is a metric? Because we are evaluating it, right? How many number of hops? It is only one. In that scenario, it was only one. So we are evaluating. So maximum hop count, they are not telling minimum. They are not telling restrictions. They are making some limitations here. So what is the limitation? The maximum limitation of the hop count should be only 15. It can't go across that. The limitation is 15. It may be your objective question. Please recall this. It should be 15. If the hop count is more than 15, the destination network is unreachable. The destination network is unreachable. I think you have seen this scenario in your command prompt. Once again, I'll just go with this command prompt. IP config. Sorry. Have you seen this scenario? Trace route google.com. Have you seen this? Yes or no? More than 15, it doesn't work. If it is a RIP. So can you see, Geo is my service provider and this was my gateway. Can you, if you can recall, it is entering my gateway and it is entering there. So routing information is being added to each and every routers. All these are routers in between. 10 dot, 172 dot, 192 dot, 172 dot, 172 dot. All these are the routers in between to reach that server. To reach that server, all these are the routers. So one router is trying to fail. So it will immediately construct the immediate path. So the request is timeout now. Yes, some router is trying to give the significance that saying that I'll not be able to reach this server. So immediately it gave to some other router, the next immediate router. They are host. No, they are not the host. They are not the host. Can you see? Within 15. So what is this? The total number of traces. Within 15 hop count, I was able to reach this server. Did you witness that? See, this is the same address now. The same address. I was able to reach the server within the minimal hop count. Got it? Yes. Okay, I think guys, I've got an urgent meeting now. You can take the break. You can take the break till 2:15. Please join 2:15, sharp 2:15. I'll join. I can't give 2 hours break. Yes. Can take the break. 2:15. $2.15.